So today we are going to look at linear models. We'll see as we go through the lesson what we mean by that. First though, there are some definitions to go through. So let's just recap some things. So first of all, a variable. So a variable is a letter. We've been seeing lots of those, and why do we use letters? Well, it's essentially to represent a value that can change or vary. So for example, maybe you're looking at people's salaries in a company. There's not just one salary in a company. A lot of different people have different salaries. So you might need a variable to represent that in terms of some sort of equation involving salaries. All right, next we have an independent variable. So what is an independent variable? That's the variable you need to know of first. That's kind of your starting point. And it's the value that determines the value of the dependent variable. So dependent variable, that's what is affected or changes based off the original first variable. And on a coordinate grid, so on a graph, the values of the independent variable, they are the ones that go onto the x-axis, and that's going to be very important. And this doesn't only apply for math, but if you've been taking science, that's definitely an important thing in a science course as well too. A dependent variable, that's the one that's actually being changed by the independent variable. So we say it depends on the independent variable. And so on a coordinate grid, that's the one that goes onto the y-axis, or we think of it as our y value. Then we also have a couple of other definitions. So once we actually create a graph, we have some points, or we have some other way of representing our relation, we can use that information that we have to make estimates or guesses as to what other values could be like that we don't necessarily have points for. And so that's what we're going to call interpolation and extrapolation. So you're using the information you have to make some sort of educated guess. And interpolation basically means you're estimating values lying within elements of the given data. And so you're estimating coordinates between those that are already plotted. And extrapolation means you're basically taking an educated guess at something outside of the range of the given data. We're going to go through a couple of examples to really illustrate what that means later on. Okay, so that's a quick run through of definitions. Now let's get into some examples to see what we mean by these terms that we've gone over. So first of all, let's practice identifying between independent and dependent. So we have some examples here. So let's take a look at the diameter of a tree and the age of a tree. So we have two different, let's say, things, variables. So you could have the diameter of a tree, the age of the tree. Those are the two things. So we want to know which one is independent and which one is dependent. Well, what do we need? We need to figure out which of them would come first, or which one would be affected by the other one. In this case, if we think of it as a tree gets older, the diameter of the tree would grow. I mean, the age is what is causing the diameter to get larger. And so that's actually going to mean the age is our independent variable. Whereas our dependent variable, what's being affected is the diameter of the tree. All right, let's take a look at the next one. So the amount of flour used and the number of cookies made. So what is being affected by the other variable? So we have the amount of flour and the number of cookies. Well, the number of cookies being made, that's affected by how much flour you have. So we're thinking in terms of independent and dependent. Well, since the amount of cookies depends or is affected by the amount of flour, we can label that as our dependent variable, so number of cookies made. And so that also means the amount of flour must be the thing we're starting with, so our independent variable. Okay, let's take a look at a couple more examples. So what if we have the number of likes an Instagram post has, okay, and the number of followers the actual poster has. So which affects the other one? In this case, I would say the more followers you have, the more likely you're going to have more likes. So we're starting with the number of followers. So independent is number of followers. And in a sense, that's going to cause there to be more likes, assuming their followers are actually engaging with their content. So number of likes. Because somebody that has millions of followers is definitely going to be able to rack up tons of likes compared to somebody with only 100 followers. All right, and the last one, the amount of money earned and the amount of time worked. So what do you have to do first? Well, you have to work. You have to work some amount of time before you can actually earn the money. So the amount of time you work is going to be the independent and the dependent is going to be the money you earn. And that's going to be the case for a lot of these examples. When we're looking at things like money, earning money, that's usually the dependent, and we're changing something to see how does our money earnings get affected. And that's not just in this lesson, but very common for many applications, because oftentimes things like businesses, whatever it might be, we're always looking at how much money is made, and we always want to see what affects that income. And so it is a very common dependent variable. All right, so when we're graphing, as we said before, the independent variable always goes on the x-axis. I'm just repeating that because that is important. So let's go through this example and let's see how we can make use of graphing things and estimating values. But first, we'll have to identify our variables. So the data shows the relationship between the number of people attending a banquet and the cost to actually basically put on that banquet. So we have a table of values there. And we want to first of all know what variables could we use to represent each of the properties being measured. So the properties are, as in the number of people, that's our one property, and the cost. And so, we don't want to have to write those out all the time, each and every time. That's why we use variables. So instead of saying the number of people equals so-and-so times cost, we want to have a more efficient way of writing things down. So what we're going to do is we're going to say we're going to figure out some letter, and then we're going to say represent. So whatever letter we choose is going to represent the number of people. And for the number of people, I like to use the letter N for number. So that's a fairly common one. You could also use X for X variable, but you don't have to use X and Y, but it is fairly common. For cost, well, C is just short form of cost, so we can use that as our variable. So let C represent the cost. Now, whenever we're referring to those two things, we can just say C or N and save ourselves a bunch of time. Okay, so which one would be the dependent? Which one would be the independent? Well, what are we starting with first? We need to know how many people we have at the banquet. Then based off of that, we're going to have some sort of cost. So the independent is the number of people. And that means the dependent is the actual cost. Okay, so that's identifying our variables. Now let's go ahead and actually graph this relationship. So to graph the relationship, to make a real proper graph, let's go through the steps. So first of all, we want a title for the graph. So how does the number of people affect cost? So we have a title, and we underline the title. If you have a ruler, make sure to use a ruler. That's always a good practice. Next, we need our x and y axes. So we said the independent variable, so in that case we said the number of people, that's going to go on our x-axis. So we're going to label that as the number of people. Again, I'll underline that. And the cost, so we can think of that as y and x. The cost is going on our y-axis. And now we want to figure out, well, what numbers are we going to put on the scatter plot or on this graph? So for the number of people, you can see it nicely goes up by tens, and you just want to space it out so that it nicely fits, because if you did it just like every one, like 0, 10, 20, like just like what I'm doing right now, you can see my graph just ends pretty much right here. That doesn't make good use of the space. So if you see that's going to happen, just space it out a little more. So I'm going to do every other one, allow it to take up a little more space. And if there's a little bit afterwards, that's okay, because sometimes you do want to just have space to make extra predictions, as we'll see later on. Okay, next we have the y values. So the y values are going up to 1100. I'm going to go up by 100 for each unit. And you don't necessarily have to write down each unit. So you'll see I wrote down the first 5, but if you did every other, like this, what I'm going to do afterwards, that would be totally acceptable. And that would save you a little space, and it just makes it look a little cleaner with not so much clutter. All right, what's next? We have our labels of the axes. We have the numbers. Now we can actually find and plot the points. So again, when you're plotting the points, your x value and your y values here, using that to plot the point. And I'll plot in purple. So we're starting with 0 people for 350. So we're going from 0 to 350. Next, we have 10 people at 500. So see, that goes there. 20 people for 650. 30 people, so across to 30, and then up to 800. 40 for 950. What you'll see is actually these points are looking like they're going to make a nice line, so we're definitely going to make use of that later. 50 is going to go all the way up to 1100. There we have it. We have our points. So since it does make a nice line, if you can try to draw a nice linear, I have to erase the whole thing. It doesn't like erasing only parts. But yeah, try to use a ruler and get a nice straight line like we have there. Okay, there is our graph with the points and joined by a line because it created a nice linear relation. Now let's answer the following questions using this graph. So the first question we have is, can we use the graph to estimate the cost of having 25 people at the banquet? So in our original table of values, we didn't have the number 25, but now that we have this plot, what we can do is we know 25 people, that would be right there on the number of people part. So that'd be 25 people. So what we need to do is we need to go follow this upwards on the graph. Let's just make that a little neater. So we're going upwards and we're just seeing where does that reach. And it basically reaches right there. And so what is the Y value associated with that 25 people? So go across and you can see the Y value is 700. So by using the graph, even though we never had a value for that, we can make a pretty good estimate of what it should be. And so we could say that the cost would be, well, we said 700 was the value on the graph there. And so we call this particular estimate an interpolation because the actual point we found, the 25 people, that was within the range of data that we originally had. So it was between 0 and 50, was in between the number of people. All right, what about this next one? So use the graph to estimate the cost of having 60 people at the banquet. Well, this is where things are going to be a little different. So for 60 people, let's do this in blue. So 60 people is right here, so 60 people. And work your way up from here. But what you're going to notice is, our data is all to the left. And that's where we have to use the general trend that we have. So that purple line, we could just kind of keep it going. So it could keep, oh, didn't mean to fully erase that. Let's go back. That purple line, we just want to see if it kept going, it would keep going up and up like that. And you can see the blue line hits right about there. So where would that be? That's just right at the top. And that joins at about 1300. So Y value of 1300. Okay, so then if we go down, we can include that. So the cost would be, well, 1,300. And because when we were looking at our graph, that value that we were originally looking at, that 60, that was to the right. That was outside of our original data. On our table of values, we ended at 50. We didn't go anywhere past that. So by making an estimate outside of your data, that is what we call extrapolation. Whereas interpolation was within the data. So that's the difference between those two when we're talking about making estimates. Let's take a look at this last part. So if we're estimating the number you could have at the banquet, if let's say you could spend $900. So that's another important thing to be able to look at. You have a budget. How many people could you actually fit in? So this is where we have to start now with our Y value. So our Y value, we say we can spend up to $900. So now we see where does that go to. So we just go horizontally across and see that it lands right there. And so then we see what the corresponding X value is. Again, using a ruler will allow you to get this as exact as possible. And you can see it's just a little bit past 35. It's slightly to the right of that particular part. So I'll just say about 36. And so we could have 36 people. And again, that was within our data. The original y value was in between the y values that we had. So therefore, that would be an interpolation for this last one. Okay. So that's looking at a graph, all that we can do with it, and what interpolation and extrapolation are. Let's take a look just at a couple more examples, again, of identifying variables and then creating equations based off of our words. So Shane, he's decided to mow lawns, and he's charging a base fee of $5 for gas plus $10 per hour. So what depends on what? Well, if we're looking at money, oftentimes, as I said before, that's going to be what's being affected. So that's what's changing, depending on some other thing. So in this case, since we're charging money, we'll say the total charge. And what is actually affecting the total charge? Well, it says here we normally spend $5, or that's like our base fee, plus $10 per hour. So the more hours we mow lawns for, the larger our charge. So it's actually the total hours. That's what's changing. Maybe we work 5 hours one day, 10 hours the next day, and that would change the total charge. Now let's make an equation. So I'm just going to quickly label these with some variables. So I'm going to say total hours is H, total charge is C. So our equation would be the dependent variable is always going to be the thing that's equal to something else because it depends on the other thing, and it's what we're calculating. So the total charge, or C, is equal to, well, we have a $5 base fee, so we can say $5 to start off with. And then we have directly in here saying plus. And what are we adding? Well, $10 per hour. So each hour, we're getting $10. So 10 times H, because we need to figure out how many hours we're working and multiplying that by 10. All right, let's do another one of these. So Yuvika ordered paintings from a local shop that charge a basic fee of $50 plus $8.50 per painting. So maybe she's getting like a set of 20 paintings of the same one. So there's a base fee to it, plus just how many are being printed off or done. So again, what's being affected? Well, depending on the number of paintings, the total cost is going to change. So the total cost is our dependent variable, which we'll represent with C. The independent variable, what's actually impacting that final cost? Well, that's the number of paintings. So number of paintings. Whether we get just one painting or 20 or 30 or 40, however many Yuvika wants. And I'll represent that with an N. So when we create the equation, again, the total cost, that's the thing that we're finding out in the end. And we have a basic fee of $50. So we're beginning with that basic fee, so we can just write that down. And then plus, what are we adding on? Well, it says $8.50 per painting. So we need to know how many paintings we have. And for each one, we're multiplying by that $8.50. So it would be plus 8.50 times the number of paintings. So if we had 2 paintings, it would be 2 times 8.50. If you had 10 paintings, 10 times 8.50. You would just replace that N value with the number of paintings. And that is our general equation. All right, so that's everything for this lesson.